Pleasure to welcome Dr. Solène Kalénine. She is a researcher at the Center for National Scientific Research in France. After initial training in clinical neuropsychology, she completed a PhD in cognitive psychology. She worked as a postdoctoral researcher, contemporary with me, at MRI, mentored by Laurel Buxbaum. And today, so she's come back to Moss this year, funded by a Fulbright mobility grant to conduct research on individuals with stroke that she's going to tell us about today. Well,
Thank you. Thank you, Rita. Hi, everyone. People online. I don't see you. I don't know if I can hear you, but yes, I'm sure I'm going to be able to forward questions. Okay. Yes, I'm going to talk of something a little broad today, just to give you a little bit of a flavor of my research program, and then I hope to have enough time in the end to present a few preliminary data on the project I've been conducting this year. So the title of presentation is Action and to Access Words and Concepts. And I'm grateful for the fair family for being able to give this talk today. And I'm going to pause on this slide for those who need credit. So the credit code is 41 FESS. And apparently, I'm supposed to, so you put it in the chat, or should I do it?
No.
Okay. Ask me again at the end of the talk if you miss it. Okay. Interest. And here are a couple of objectives for today for this presentation. My goal is to make you comfortable explaining what it means for cognition to be grounded in the sensory-motor systems. I also would like to explain to be able to give a few examples of situations where used gestures may help people retrieve conceptual knowledge and words. And finally, to be able to discuss how images may serve as supporting materials to convey and prompt gesture information in people with aphasia. So a short outline of my presentation today. I will just introduce myself very briefly to understand also my scientific background before introducing grounding views of cognition. This will lead us to the neural substrates for action and object knowledge. And I will also present a few studies that use gesture to access object knowledge and words before presenting the project funded by the Fulbright program and the PRC committee here. Okay, so I'm a researcher in France at the CNRS, which is roughly the equivalent of the NIH, although it doesn't work exactly the same way. And I have indeed a clinical training in neuropsychology, but I've never practiced neuropsychology in the clinics, unfortunately, or fortunately, I don't know. But because I really became very interested right after my clinical training in cognitive processes. I wanted to study more cognitive processes. And that's how I ended up doing a PhD in cognitive psychology. And my PhD thesis was in the domain of conceptual development. So how kids and even throughout life, we build semantic categories of objects and entities. And so I was studying the mechanism of categorization and category formation. And that's when I started to be very interested in the role of sensory-motor experience of children and young adults in the formation of these categories. And so then I wanted to know more about action, sensory-motor knowledge, and that's how I been in contact with Laurel Buxbaum and MRI here in order to study how actions may be represented in the brain. And I spent 3 years here, and I learned a lot about action and cognition. And now that I combine these two lines of interest, and my research program focuses on these interrelations between object knowledge, categories, semantic categories, concepts, and action knowledge, action representation, sensory experience. So basically, all my research is around these two orders. Concept. Okay, and so I talked about the sensory motor experience and how this may also participate in the formation of categories. And this is actually a core assumption of grounded views of cognition. So if I show you from this picture, you can think about many types of information that might be relevant for this picture. You may think, oh, yeah, I recognize it. It's a mug. We will to say the word, think that it's a man-made object, that it has a handle, can be used to drink coffee, also some other properties. It can be hot, some category information, it's a kitchen tool. So all of this information is what we can think of the concept of the mug. So the representation of the mug, I'm going to use this as synonyms here. So the concept, the representation, the semantic representation of the mug. And researchers for many, many years have been interested in how we form and access this kind of conceptual knowledge about the objects of the world. So how do we recognize the cup? How do we recollect all this type of information? And I'm going to be very schematic here, so I apologize for those who would like more refined definitions, but I'm going to talk about here what people have considered traditionally, so I call traditional approaches of cognition, in how we build and access this type of conceptual representation about objects. So, and the traditional views consider that this concept is kind of isolated from perception and action. So we have an input here. For example, here we're going to perceive the mug, and then this will activate a kind of isolated, disconnected representation of the concept of the mug. And once this representation is activated, then we'll be able to act with the mug, on the mug, or to do things in the world. So according to these traditional approaches, perception, action, and representation are kind of disconnected, and hierarchically organized. You first perceive and then you act. And in the middle, you have this representation. So this is really the theories that have been prominent during the 80s, because also of the rise of the computer science. So this is the way I think about these approaches. It's really the drawer kind of a metaphor. So if I see something or if I hear something, I'm going to have to access something, knowledge that is stored in I'm going to have to open the mug drawer and try to find the knowledge that is in that drawer. And so this is pretty disconnected from how I interact with the world. And in contrast to these views, these modular views, grounded views of cognition consider that perception, action, and representation are highly interrelated. So it means that there is no clear disconnection, clear separation between perception, action, and concepts and representation. And our interaction with the world are part of cognition. So this is a little more messy. This is what you would think of when you see the drawing on the right. So these are really broad framework. There are different models, different finer grain refinements, but this is the core idea. And according to these views, cognitive processes could be memory, could be language, it could be thoughts in general, are considered simulations of previously acquired sensory and motor experiences. So you're gonna, when you think, when you process something cognitively, you have to actually re-instantiate in your brain the experience that you had before with the entities that are in front of you. And so, and these experiences are perceptual and motor inherently, and so you're gonna have to reactivate all these brain areas that were at play during your experience with the object and the entities. So according to this view, access to object concepts involves retrieving perceptual and motor information because it's part of the concept. It also means that accessing object concept means relying on a distributed neural network that includes sensory motor brain systems. And importantly, it means that access to object concepts is influenced by how we interact with objects. So if you look at this last assumption, this means that depending on, this is of course very schematic, but depending on how, what type of experience you have with the entities of the world, you're gonna rely on different sensory motor systems. And so you can have a different way of representing the concept. So if you think about animals, such as an elephant, you may have mostly visual experience, maybe some sound experience with these animals. And so when you're gonna have to represent the concept of an elephant, you're gonna have to simulate this kind of visual and auditory experience in your brain. And so this concept will rely a lot on those systems. For example, a piece of fruit, it might be more other perceptual system that might be involved in particular, such as smell or taste. And for manipulable objects, it might be more motor interactions, motor experience that might be at play. So depending on the type of concepts, you may rely put more weight on one or another perceptual or motor system. What's also interesting, it's a bit of a side note, but with grounded views of cognition, it means that they also consider that differences are the rule between individuals and between situations. So let's say, so what's the content of a cherry? According to these views, the content itself of the cherry, it's not the definition of the dictionary. It depends on how the situation you are. If you are trying to pick up a cherry on the tree, then the concept in itself of the cherry will involve a lot of motor experience, motor simulation. You need to think about how to shape your hand and to grasp it. So this would be in the foreground. But if you want if you are trying to determine what type of pie this is by tasting it, then the concept of cherry will not rely on motor experience and might rely more on taste or smell. And same thing if you are trying to decide which type of cherry you would like to buy. Maybe it's more like the visual experience with cherries, but the color that would be simulated. So the content itself of the concept of our knowledge may vary depending on our previous experience and the situation that we are facing right now. Going back to the different types of objects and entities, in this big framework of grounded views of cognition, my work has mostly focused on the representation of man-made manipulable objects and the role of the motor systems in the knowledge for this type of object. And so if the motor experience is part of the conceptual representation of the type of object, it means that we should have overlap at the also at the brain level in the substrates for action and object knowledge. And I'm going to present a few arguments in favor of this assumption. So what about the neural substrates of action knowledge? I'm going to just give you a few examples of study. There are many. I tried to pick the ones that have been conducted in patients, but of course you have a ton of neuroimaging data on this topic. So the first study is a study that looked at the neural subset of actual tool use in acute left stroke patient. So they have, I think, 150 patients. So this is a very large study. And they looked at the brain lesions. So this is not a map of activation. This is a map of brain lesions that are associated with a particular performance. So here, the performance of actual tool use. And so you can see that actual tool use, so the people who have lesion in the red areas here in this kind of big triangle that includes a large part of the infraparietal cortex and also part of the superior temporal lobe is critical. These regions are critical for a good tool use in these people. And this is another study that we conducted by the Laurel's group, or Bertrand group, on this time, though the participant, it's a slightly different task. They had to gesture to the site of tools and not to actually perform the tool use. And you see that they find again that this region, so that they have two important regions for this type of task. And one of them is again this kind of triangle that overlaps across the infraparietal cortex and the posterior superior temporal cortex that is necessary for being able to gesture to the site of tool. And importantly, they showed in this paper, it was really nice, that poor performance for gesture to site was actually associated with structural disconnection within this network. This is the first study I conducted during my postdoc with Laura Bergsbaum. That it was at this time on gesture recognition, because the previous study showed that you need this region to be able to plan a gesture toward an object, to use gesture toward an object, but it doesn't mean that you need the same region to be able to represent this gesture offline, even if you don't need to act. Just, for example, if you need to recognize someone else doing the gesture. That's the question we asked here. So we use this gesture recognition task where patient heard an action verb, let's say a cone, and they had to decide which one of two videos of gesture matched the verb. One was the correct one, and the other one was a foil, and the foil could be another gesture, but correct for another object, or a slightly different gesture with spatial or temporal errors. So they had two versions of the task. And what we, so this task has been used in a couple of studies, but here what we show that the brain region that were necessary to recognize the gesture in both versions of the task were a large part of the temporal lobe, and this actually was also critical for just, we had a control task for understanding the verb, but importantly, we had also again, temporal, posterior, and inferior parietal region that were specifically critical for the recognition of the gesture. So overall, it seems that the posterior temporal parietal cortex is critical for representing tool-use gestures, regardless of the situation. If you have online when you need to plan the gesture, but also offline when you need to just watch someone performing the gesture and you're trying to make sense of what you see. Okay, so now do we see similar brain regions when people process manipulable object concepts? And I wanted to show you this study because it's I think pretty neat result. It's a study in people with temporal lobe tumors. So the tumor actually encompassed a little more than temporal lobe, but all of them had temporal lobe tumors. And they looked at naming artifacts and naming animals. And then they looked at what were the regions that were selectively associated with animals versus artifacts and vice versa. And what the main finding is that they show that if you look at the brain region associated with naming artifact while controlling for animal naming performance, it seems that you have a large part of the posterior temporal cortex that also includes part of the interparietal lobe. So these regions are necessary to name artifact objects, even if you control for naming performance in general. So this is for, I would say, accessing just individual concepts, but what about more, a little more elaborate semantic tasks where you need also to put objects together, to categorize objects. So this is a study we conducted a couple of years ago with Lord Bugsbone on the neural substrates of different types of categorization. We compared what we call thematic and taxonomic categorization in people who had a left hemisphere stroke. So we had a very simple forced choice task. You had a target and two pictures of choice. One was semantically related, one was not semantically related, and they had to identify which one was semantically related. And depending on the condition, the semantic associate could be thematically related. It means two objects that play complementary roles in the same event. So it's a type of semantic relation, but it's not they don't have similar features, they just have this kind of complementarity relationship. And we contrasted this with taxonomic relations, so two objects of the same kind that share features and are from the same semantic category. And we verified, this is also important, but we verified that the strength of the semantic association was similar in both conditions. So people tend to say that this is as much associated than that. And then we looked again at the brain region that were critical for the identification of thematic relations for artifact objects. So the axe-log relation. And we saw, this is the top map, we saw that again, this kind of triangle of voxels overlapping between the infraparietal lobe and the posterior superior temporal cortex were the voxels that were critical for identifying thematic relation for artifact, controlling for the other, for general categorization performance. And interestingly, in that study, we asked the same participant to also perform the gesture recognition task. And the map below displays the brain region, the voxels that were critical for gesture recognition in that sample. And we have a very strong overlap in this sample of in the posterior temporal cortex for identification of thematic relation for artifact objects and recognition of object use gesture. They are not the same items. It's just a different task, but on one hand, the identification, categorization of manipulable objects, and on the other hand, gesture recognition seem to really rely on the same brain region in the posterior temporal cortex. And just to, I would like to also to mention this very elegant study that was conducted by the Mina Schwartz group a couple of years ago, to show you that this is not specific to the visual modality, because we see gestures, we see objects, but that we have also arguments to showing that thematic relations rely on the posterior temporal cortex also when it doesn't involve images. And so this is a study where they looked at naming errors in people who had aphasia post-stroke, and they distinguished between two types of semantic errors: the thematic errors, such as when you say one for apple, or the taxonomic errors if you say pear for apple. So of course, thematic errors are more rare, so people have not looked at it carefully before. But here, they were able to show that actually this type of error, saying one instead of apple, was associated with specific lesions in the temporoparietal junction. So even in a task that has nothing to do with the visual modality or with the objects per se, thematic knowledge seems to be associated with this posterior temporoparietal region. Okay. So again, this is a little bit off my talk, but I really wanted to show you that it could be interesting also to rely on this kind of action-grounded knowledge with patients. And for example, we looked here in a series of studies to thematic relation in people with semantic dementia. And this has been done with a neuropsychologist in France who is an expert on the semantic dementia, works out with this type of patients. And what was the rationale here? It's like, okay, so we know that in semantic dementia, there is a progressive atrophy of the anterior temporal lobes, and that leads to severe semantic deficits. But early on in the disease, the posterior part of the brain is relatively preserved. And if we see that thematic knowledge is selectively grounded in the posterior temporoparietal cortex because of its relationship with also action knowledge, then it might be that this patient may have residual knowledge thanks to the relative preservation of this part of the brain. So we use again this categorization task, this four-choice task in people with semantic dementia, and we contrast it to taxonomic and thematic identification. So are they able to say that the axe is related to the log and or to the drill, depending on the condition? And what you have here, it's so the percentage of correct responses for three groups. We had a semantic dementia group, a group of control patients with Alzheimer's disease, and healthy controls. So semantic dementia is blue in blue, Alzheimer's disease in gray, and the healthy controls are in black. And we distinguish between the four conditions, so taxonomic on the left, thematic on the right, and we divided between artifact and actual concepts because we know that there might be differences there. And the main finding is very interesting is that, of course, they were overall very impaired, the people with semantic dementia, more than people with Alzheimer's disease, in all conditions except one. And the only one that they were equal with performance with Alzheimer's disease patients was the condition for thematic identification of artifact concepts. So this type of relationship.
Solène, can I ask you?
Yeah, sure.
Still puzzling over the Schwartz et al. Because there, the lesion in the temporoparietal area leads to a preponderance of thematic errors.
Yes.
But it's lesioned. So wouldn't you expect fewer thematic errors?
Yes.
Isn't it contradictory to this?
Yes. I don't know what kind of I don't know if it means that we don't know yet with when we have lesion there if it kind of, since there might be complementary systems, if it decreases the activation or increases the activation of this type of knowledge. We have had different
or is it a control center? Doesn't Laurel talk about like the parietal lobe has also like executive control functions?
Yeah, I know there have been a lot of discussion about whether if you compare thematic versus taxonomic categorization, the differences that are observed in these two types of knowledge, do they actually refer to differences in cognitive control? It's a huge literature. Honestly, I'm not sure. I'm not convinced now that it's purely that. Even when it's controlled, it's not clear. There have been different contradictory results. I think some of them showed that in certain circumstances, thematic would rely more cognitive control than taxonomy. In other studies, it's the reverse. I don't know, at least in my study, I will try to equalize really the difficulty of the task for the two conditions when I was trying, and I saw, so I'm not saying that thematic errors are not actually to do with deficit in control. I'm not sure that it's only that. And I found the coincidence between this type of region involved in thematic errors and also in thematic identification in many other studies to be a little bit surprising. It's just a coincidence, you know. But I agree that there is a role for cognitive control, but why would it be mostly for thematic knowledge? I think we need cognitive control also for semantic control, also for taxonomic knowledge, depending on the strength of the association. I don't yeah. So yeah, in that study was found very interesting is that this is the only condition where they were, so because people with a, sorry, you had a question? No. Yes, okay,
Go
please.
ahead.
No, please.
So I'm sort of thinking in two ways. So we started with how a object might have multiple different representations, if you will, or a representation is developed based on multiple sensory, motor, memory, and all of those pieces. And so the fact that this particular area that is the superior temporal, superior parietal, that area, is it, so how do you think about this? Is it that it is a part of, or it represents all of these processes, or it is a region that contributes to multiple representations? Because I'm seeing that area being involved in multiple different
Sure.
tasks. So is it that area is responsible for forming those things, or it represents some higher level process that then controls all these representations? I'm not sure if controls is.
Yeah, I think that this area can support some higher level processes, but so I think it is. I mean, we know that it's not the TPJ is not only about action. I'm not saying that. I'm saying that in the task that we have been using, we always saw that this region was selectively involved in one particular condition, that there was no reason that this condition was more demanding on any other thing than the other. If you look at this is really the same type of task. And it's also weighted by the type of concepts. So we control for the strength of the semantic association between the target and the associate. When we looked at so going back to the lesion data, we really contrasted. So we were looking at poor performance here compared to the exact same target here. So I agree that there might be, of course, in categorization task, you have a ton of higher level cognitive control processes involved. This is certain. But then, why would this type of high level process be involved more in one particular condition when you equalize the difficulty? So that's I think it's not only that. I'm sure that overall, if you look at, so in this task, I have also during my PhD, I ran with the same type of stimuli, I ran an fMRI task to contrast the two type of categorization. I got similar results, but the important point that if you, for this question, that if you look at the brain region involved in semantic categorization, you have the whole brain. So of course, if you look at semantic categorization overall, everything is activated. But then when you contrast directly really different conditions, then you see differences, and in particular differences between involvement of more anterior versus posterior areas. And I don't see why this would be more related to cognitive control in that sense. But I agree. I'm sure it's both overall. And here, again, they are all impaired compared to people with Alzheimer and analytic control. So I'm sure they have many deficits related to language and or cognitive control. But why would they be relatively preserved only in that condition? So it's just this type. If you put like an animal, like a dog leash, they are here, they are really impaired. But if you put something that can rely on more action, kind of more motoric experience, then they are closer to the two control groups. So I think there are still, and it's related to their and we know that they have more preserved, relatively preserved posterior temporal cortex compared to the anterior lesions. And we have similar result in another study with these people. Not exactly the same sample, but it's also people with semantic dementia using a more implicit task. Here we used eye tracking in the visual paradigm. So the participant here pan and has to localize the pan in the display. And we manipulate the type of distractors. One is semantically related and the other ones are unrelated. And the typical effect is that while you are trying to localize and identify the target object, you look more at distractor objects that are semantically related compared to unrelated distractors. So you would look more here at the kind of bone compared to these two while you're trying to identify the path. And here we compare two conditions. One condition where the semantically related object was a taxonomic distractor, and one condition where it was a thematic distractor. So we compare like pan, ball versus, it's in French, so maybe the word we selected were not as meaningful as they are in English. But anyway, this is, so stove and pan. And what we saw here is that people with, so we didn't have a patient control group, we just have healthy controls and people with semantic dementia. But healthy controls, they look more at ball compared to the others when they try to identify pan. But the people with semantic dementia, they showed no competition. They didn't show this pattern at all. So they looked similar to the three types of distractors in the taxonomic condition. But in the thematic condition, they did show a competition effect with the thematic distractor. So they looked more at the stove compared to, let's say, the turtle when they tried to identify the pan. And it was even more than controls, actually. They showed increased competition. So this is difficult, and they didn't show a lower taxonomic competition. They showed no competition. So that's a little difficult to understand in which direction the effect is going to go. But it seems that they have preserved thematic knowledge even implicitly, but also that they use it more in semantic tasks. Is it because it's a balance between the two systems? So we discussed it also in that paper, but this is not clear yet. But at least we have two studies with different tasks that show that people with semantic dementia may show preserved thematic knowledge compared to taxonomic knowledge. So it might be helpful for some people, depending on where the lesions are, to ground their knowledge in different sensorimotor systems. Okay. So we showed overlapping representation for action, use gestures, and knowledge about manipulable artifacts in the posterior temporal parietal cortex. So now knowing this, can we think of how to facilitate access to object knowledge, and in particular by using gestures? So there are also many different lines of research in this field. I'm just going to give you a short, like an example of each type of study of line of research. So this is a study, pretty simple, that we use in healthy adults, where we show that we could prime object categorization with grasping postures. So we presented objects, natural or artifact objects, that were all manipulable, and people had to categorize the object, saying, okay, is it natural or artifact object? And before the image of the object, we presented two types of hand postures. One was the action prime, so it was a hand posture in a grasping position that was congruent with the gesture that you use to grasp and use the object. And the other one was a neutral, as neutral as it could be, hand posture, so meaning a non-grasping hand. And what we showed, a pretty reliable, so this had already shown before, but we confirmed that there was a priming effect of the hand in a grasping posture. So when you see the hand in a grasping posture, it facilitates the categorization of the object. And in this study in particular, we showed that it was driven by artifact concepts. So the effect was present overall, but when we looked at the different types of item, it was driven by the categorization of artifacts. So it confirms the close relationship between manipulable artifact concepts and action. If you put the broccoli here, it's less relevant. This is also a huge line of research in education, the use of gestures to facilitate access to object knowledge and words. So this is just an example of many studies in this literature looking at gesture enrichment in the context of a novel word learning. So most often it's done in a second language acquisition. So here, for example, in this study, it was in Spanish. And they showed healthy adults and children novel Spanish words that were presented. Either they just had the translation, or they had the picture, or they had the gesture. So here, the gesture that would mimic a tent. And what they showed that from grade 8, there was an advantage of both picture and gesture enrichment compared to no enrichment in word learning, but it was even greater when it was the gesture compared to the picture. And actually what shows this graph below is that the effect, the differences between the condition lasts after 6 months post-learning. So it's pretty long-lasting effect. And again, there are many studies in this direction in the more educational literature. Here, this is in people with stroke. This is a study that has been conducted by Lowell and Gabriela Glocco's lab. So many of you might know this study already, but just show you that we have also consistent evidence in people with aphasia. I'm just going to show this. This is a pretty complex study, so just show that the people were asked to decide whether an image matched a word. So here they saw a pinching image, and here someone saying pinching, and they could see these two stimuli in 3 conditions. And in one condition there was no gesture. In one other condition, the person saying pinching was also doing a congruent gesture, so pinching, and in another last condition, the person was doing an incongruent gesture. And so in the speech task, people had to determine whether the picture matched the speech in the video. And they looked at the effect of congruent speech. Oh, sorry, congruent gesture on speech. And the congruent gesture benefit here, that's what you have the blue condition here, was associated with spared lesion of the temporal parietal cortex. So people who had lesion more anteriorly had a benefit. People who had more posterior lesion didn't show this benefit. And people who had lesion posteriorly showed benefit in another condition I'm not going to describe here. But what's important to keep in mind is that to show this kind of gesture advantage, you need to have lesions that you you must not have lesion in the postparietal and temporal cortex. A last example of study in people with stroke. Here they looked at how to facilitate action naming with gesture observation. So people with post-stroke aphasia had to name an action picture. For example, someone doing chopping and a chopping action, and then they had to just say chop. And the picture was preceded by 3 conditions, either nothing as a baseline or a gesture video. And the gesture video could be congruent or unrelated. So either the same, the congruent gesture or an existing gesture, but for another object, vacuum. And what's interesting that they showed a benefit of congruent gesture over unrelated gestures for both correct responses here, so the correct naming, but also for reaction time, so naming latencies. It's even more obvious for naming latencies, actually. So this is something I'm considering also for the project I will present later. So should we expect the benefit to be visible on the ability to say the word or to the speed also of naming? Okay. Almost there. So so just to conclude about that observing congruent gesture can facilitate object categorization, word comprehension, and word production. And this has been shown in healthy adults, in children, and in people with language difficulties after stroke. So I think that all these studies are really interesting, but what I was thinking when I look at these studies, that it's pretty difficult to show, sometimes to show a whole gesture video before naming or before trying to do a categorization task. And I was trying to think about more implicit ways of conveying gesture cues. And I thought that maybe images could be an interesting support materials to display gesture cues. And this is actually the project I'm doing here this year, the Motor Word Learning Project, in collaboration with Laura Braxbaum, Erica, and Shona. And the project is supported by the Fulbright Mobility Grant and also funding from the PRC of Marc Rehab. The objective was to evaluate the benefits of learning or relearning object nouns with gesture cues on lexical access during word production and recognition in people with language difficulties following stroke. So the idea here was to try to display the gesture cues directly on the object images that are used during the word learning and retrieval practice exercises. So this is one of my items. So we picked low frequency nouns of manipulable objects. So usually the object per se are relatively familiar, but they might be known, but the name of the object is considered low frequency according to normative data. So here you have a schema. So didn't knew the object, but didn't know the word. And so the idea, okay, when you try to practice naming or try to work with this type of item, is it helpful to have something like that? So if you show directly with the object the image of a congruent gesture, congruent for the use and the grasp and the use. So just imagine that you see this picture and then you learn or you relearn what a skimmer is. So a skimmer is a flat spoon with holes in it. A skimmer is used to remove foam or food from the surface of a cooking liquid. And is it better if you see also the correct gesture at the same time? And as a comparison, you need to have a good control also condition where you also see a hand, because otherwise it could just be that the hand is more interesting in general. So we compared this condition of learning with a condition where the image of the object was displayed with neutral gesture cues. And here we try to have gestures like pointing or just raising hands. So hands that would not convey the information of how to use the object, but would be still on the picture and cover kind of the same part of the object. So people been exposed to to learning and practicing word retrieval in these two conditions. So we aim to have 20 participants with aphasia after left hemisphere stroke for this project. And this is a learning protocol with 3 phases and 6 sessions where people will learn 48 nouns of low familiarity nouns of object. I'm going to detail the whole learning protocol here, but you see that they have a couple of tests as baseline, a couple of tests after learning, and in the middle, 2 learning sessions. One is more devoted to learning the semantics of the object, and one is more driven to naming practice. What's important is that for learning, the 48 items are divided into the 2 conditions. So each participant learn half of the item with congruent gestures and half of the item with neutral gestures. And here I'm going to show you just a few preliminary results, focusing on the naming test that has been conducted twice before learning, after each learning session, and twice as post-test. So we have completed the study in 6 participants so far. And I just showed you here, maybe we can come back to this later, but that they are relatively mild to moderate aphasics, but they are good functioning people overall in terms of language comprehension, at least. So what was the naming test? They see that, so for the test, they don't see any hand. The hands were just for the learning. For the test, they just had the object and 8 seconds to name the object. And then we coded the accuracy and the latencies of the name. It was the same test for the 6th session, except that for the first session where they were also asked to rate the object familiarity, the knowledge of object use, and their object recognition. And we use these ratings combined with the number of letters and phoneme and their accuracy at this first pre-test to divide the 48 items in 2 lists of 24 items based on their with equal difficulty for each participant. Um, 5 minutes for the preliminary results. So what we have here is overall, regardless of condition, the sum of correct responses out of the 48 items for the 6 participants. And I highlighted here the learning session. So good news, they learn. So they start to know about what they were able to name 1/3 of the like 1/4, 1/3 of the item at first. And right after learning, they are at least double their naming performance, and this is quite stable even at post-test. Same thing for overall for latencies, naming latencies. They overall decrease, except for this person that is a little more messy here, but in the end, even if you compare with the pre-test, they all decrease in their naming latencies. If you compare between the first session and the last session of the post-test. Okay, so overall, they improve in naming low frequency object after training, and this is visible on accuracy and latencies. What about the learning with just a cues if we compare exactly the 2 conditions? So this is for correct responses, and surprisingly, we have something a little bit unexpected here. So of course, like the significance is even if the test is significant, it's only 6 participants, so it's very we have to be very careful with that. But if you look, the action condition is the one in purple, and so even if overall they both increase their correct responses after training, it seems that it's even better for the neutral condition compared to the condition with just a cues. At least it's 1 or 2 items more. Let's see if it holds with a 6 participants. But it seems that for accuracy, learning with just a cues did not lead to more accurate naming in these 6 people. It's only a few items, but let's see. But interestingly, in contrast, we see an interesting boost of the gestures for latencies, for correct latencies. So if you look at the correct latencies, they are similar between the two conditions at pretest, and right after learning, people are faster for in the action in the action condition compared to the neutral condition. It's about half a second faster overall. And a latencies are overall relatively fast compared to the 8 seconds that we give them. They respond in about 2 seconds, and they are half a second faster when they learn with gesture cues. So we have kind of a difficult pattern here because we have a few, it seems to have a few more items correctly named after the neutral gesture compared to the congruent gestures, but it seems that the one that they get correct, so the majority of them actually, in the end, they are faster when they were learned with congruent gesture cues. So learning with gesture cues might lead to faster naming of the learned word. Yes, this is, yeah, this is it's the end. So yeah, we have to look, so training words with gesture cues may impact the speed of word retrieval rather than really like the learning. I really have to look at the items because this kind of, this might be due in only 6 subjects to only a few particular items that randomly maybe fell in this one condition or the other and that were difficult to learn. We had a few difficult items like bandoneon, which is a type of musical instrument. Shona is laughing. We have a very few items that are difficult to learn, and if by chance they fall in one condition for most participants, this might be the cause of this this 1 or 2 item difference. But yeah, we are considering also speed accuracy trade-off in the sample. But at least we know that there's something that is more about speed than about maybe accuracy in the effect of the gestures, the benefit of the gesture. We also have to look at different error types, although we don't have a lot of errors. Most errors are just non-response for the 8 seconds. We also want to look at with more people with different cognitive or lesion profiles. Of course, we expect the participant who have spared lesion of the temporoparietal cortex to benefit more from the gestures. We don't have the lesion data yet, so we haven't looked at that. We want to look also at the different learning curves, and I present only one test here, so naming, but we have also recognition tests and tests more fine-grained about that assess competition between lexical representation. So we want to also to look at that and to look at all of these tests combined. Okay, so we'll see if it's worth it to implement gesture cues on images. I hope in a couple of months. Thank you. That's it. So we have this time for questions. Kalish, you wanted to ask a question?
So I think, this lesion symptom mapping or mapping of these cognitive processes is easier on performance. But when it comes to learning and add an aspect of practice and time, things become more complex.
Yeah.
There are other processes that might interact with how practice influences.
Yeah.
So I think thinking about that might also be helpful.
Yes. So for example, something I'm trying to look at for now, just look very qualitatively, but since I have different tests, for example, I can look to my recognition test, pretty easy, it's a lexical decision task. So this might be able to also disentangle the one aspect of learning. So because they got it right, they are able to recognize that skimmer bounding words even before learning. But for a few items, they might not know the words. So I can have this variable also in my model to know whether learning will affect the word that they already know or the word that they don't know, at least from a recognition point of view. So I can combine the different tests to maybe refine a little bit the effect of learning. I agree, because this is the production plus learning, plus it's a lot of things.
And some things that might help your performance in production might actually not help in learning. And by
Exactly, yes,
thinking about those.
Yes.
is gonna be-
yes, so we have to consider also the learning curve overall, regardless of independently of condition. Yeah, I agree. Why do we thought about a learning protocol too? Because I think that for grounded views of cognition, you have to learn via your grounded experience. So you need to have like to relearn a little bit these words, the semantic of these words in the context of action. Try to kind of simulate the kind of use gesture you would use to use the object while you learn the semantics of the object before really being able to name. So that's why we wanted to have a little bit of relearning, but I agree that it makes things a little more difficult to interpret. Yeah.
And if it's helpful, sometimes you are okay with, at least I'm okay with being agnostic about what led to that.
Yeah. And I didn't show you the individual data, but it's the effect for now for the 6 participants. It seems like it's present in most of the people here. So I have to look at
Excellent talk, very interesting and nice results actually. So would you predict that if somebody was to actually try to initiate the gesture afterwards, this would further strengthen? Because it's all, and I understand exactly why you don't want to confound it actually in any movement and just
I went very quickly on that. You're right, and that's why also as a first very preliminary protocol, we actually give a chance to people to reproduce the gesture at one point of the training phase. So they have the picture, and they are trying to name the picture, but we also ask them to mimic the gesture before naming. This is the last exercise, what I call here selected SFA. So just to make sure that to reinforce a little bit this grounding, and that's also we introduced 2 naming tests, one before and one after this particular exercise. So it's still in front of they are still painting the picture, but they have to show how the person is using the object in the picture. So we added this also to make sure that it would be enough grounding with the picture at first, but we hope that this will be not the sole origin of the effect, but we have also this type of exercise implemented.
Do I assume that's just for the people that saw the appropriate gesture?
Yes. The other one they have to, for this exercise, maybe I have put this in the hand. So this is the exercise they have. Yeah, so for the ones who see this picture, they have to demonstrate the use just of their name. And this is the last learning exercise. And for the item that fall in the neutral condition, they have to provide 2 visual features to their name. So we try to exacerbate a little bit the difference there.
And just to clarify, I think you mentioned that early on that people rate their prior exposure or use of the items, because you mentioned a musical instrument that I didn't recognize, and so most people probably wouldn't have action knowledge of it. Does that make
so yes, the items were divided into the 2 lists based on these ratings about object knowledge, object use knowledge, familiarity, and also more objective criteria on the words, so number of phonemes, number of letters, and also on their first naming performance. But so also all this because all these variables are considered simultaneously in how they were split into the 2 lists. So it's difficult to say if an item was difficult because it was not familiar, or difficult because it was a long word, or difficult because it was not produced correctly at first. But this is the best we could end up with if we wanted to take into account a little bit all of this. So it's a messy measure of difficulty, but it's a measure of difficulty.
And totally unrelated, can you put the code up?
Oh, yes.
Thank you.
Thank you.
And Amy has a question.
Yes. Hi, Amy. Okay, thank you. Yes, she's asking about whether it would be relevant to have condition with incongruent gestures. And yeah, I think you have to discuss with with Anna, because she thinks that my neutral gestures are actually also incongruent. So no, and I partially, I mean, I agree with both of you. Yes, I think it's difficult to yes, I think it would be interesting and relevant, because we don't know if it's neutral. This neutral condition actually doesn't help, or if it just does nothing. I don't know how to, because maybe we could have had just the learning with no gesture at all, and consider that the neutral gesture was actually incongruent with gesture you use, with the use gesture. I'm not sure about that, because I think that the presence of the hand is really something that should be controlled for. But at the same time, of course, if you have a hand that is a non-grasping posture, it could be considered incongruent. So yeah, if you have ideas to have a neutral gesture and a congruent gesture for these images, I think would be great to discuss more. I don't know where to finish it, but yeah. Yeah. Thanks. But yeah, please, the language people, if you have ideas about how to look in further into this naming data. This is the first time I use naming as an outcome measure, so I'm not expert at all about all the subtle things that I could look at.